Spherical capacitor. It consists of two concentric spherical cells of different radii. One of it's grounded, right? Spherical capacitor consists of two concentric spherical cells of different radii. One of it's being grounded. Now first we are going to calculate the spherical capacitor with its outer sphere grounded. Let us take two concentric spherical cells with radius A and or rather with radius R1 and R2. This is the inner spherical cell and this is the outer spherical cell. Region between the two spherical cells is considered to be vacuum. We may put here another dielectric medium. Now if we place a dielectric medium, then capacitance will be K times of the vacuum capacitor, or in between the two spherical cells. If there is vacuum, then the capacitor is, if the capacitance is C0, and if there is a medium of dielectric constant K, then capacitance will be K into C0. We have proved that. In general capacitance, it is also applicable to the spherical capacitor. Now, let us say this is spherical A, which has radius R1, and the outer spherical cell B, which has the radius R2, and we consider that outer spherical cell is grounded, O being its center. Now, if we put here plus Q charge, we put plus Q charge on the inner spherical cell, or let inner spherical cell is charged by plus Q charge. Then what happens? Then there will be induced charge on the outer spherical cell, and inner side will be induced. The inner side of the outer spherical cell will be induced by minus Q charge, and outer side or outer surface of the outer spherical cell will be induced by plus Q charge, and this plus Q charge will go to R, or this plus Q charge will be neutralized by the Earth's negative charge. Now this plus Q charge disappears. Now let us find electric field at a distance R, and R is less than R2 but greater than R1. That is, we are going to find the electric field intensity in the region between the two spherical cells. Is it clear? And that electric field will be equal to what? Will be equal to Q R hat divided by 4 pi epsilon naught R square. Why this will happen? Because for this region, it is the outer point or outer region with respect to the inner circle or inner sphere. So for that case, you can consider total plus charge, that is total charge on the inner spherical cell is at the center, and for that case electric field will be this, and electric field due to the charge on outer sphere will be equal to 0. Why? Because the point in between the two spherical cell is inside the outer sphere. So, electric field due to the charged outer spherical cell will be 0 at this region, because we know that electric field inside a charged conductor is 0. So, the electric field intensity in between the two spherical cells is Q r hat divided by 4 pi epsilon naught r square. You have to find out what we are going to find out. We are going to find out the potential difference between the two spheres, because capacitance is the charge divided by potential difference or potential increase. Charge applied by the potential increase or potential difference increased. Now, potential of the outer sphere, that is Vb. Potential of the outer sphere is 0 because it is aft. Is 0. Now, potential of the A sphere or on the surface of the A sphere or the inner sphere, Va will be equal to what? Will be equal to amount of work to bring a unit positive charge from the B sphere to A sphere. That will be the potential difference, Va minus Vb, which is equals to Va minus 0, which is equals to Va, will be equal to Q r hat divided by 4 pi epsilon r square dr, where r equals to r2 to r1. R will be equal to r2 to r1, and you have to put a minus sign because r hat is along this direction and dr will be along this direction. This will be the direction of dr, and r is away from the center or away from the inner sphere, but dr towards the inner sphere. That's why you have to put here a negative sign, or you can write q r dot dr is dr q dr divided by 4 pi epsilon naught r square integration minus r2 to r1, or you can write q by 4 pi epsilon naught minus 1 minus r, and integration dr by r square is minus 1 by r, and put the limit r2 to r1, or q by 4 pi epsilon naught minus 1 by r1 plus 1 by r2, or we may write the potential difference between the two spherical cells is q by 4 pi epsilon naught into 1 by r2 minus 1 by r1 minus 1 by r2, q divided by 4 pi epsilon 0 1 by r1 minus 1 by r2. This is the potential difference. Therefore, capacitance of this spherical capacitor C will be equal to q by d. Now, q equals to q and v equals to q by 4 pi epsilon naught 1 by r1 minus 1 by r2, or we may write 4 pi epsilon naught divided by 1 by r1 minus 1 by r2, or we may write C equals to 4 pi epsilon naught r1 r2 divided by r2 minus r1. This will be the capacitance of a spherical capacitor with outer spherical cell grounded. Now, for a isolated or for a single spherical conductor or isolated spherical conductor, we have already calculated that capacitance of a spherical conductor capacitance of a spherical conductor is what? We have calculated that. 4 pi epsilon naught R. That was the capacitance of a spherical sphere or spherical conductor, right? Now, here, if we put R2 is infinite, R2 is infinite, then what we get? We get 4 pi epsilon naught divided by 1 by R1 minus 1 by infinity. 1 by infinity is 0. That means we get 1 by 4 pi epsilon 0 into R1. That means a spherical conductor can be considered as a spherical capacitor whose outer spherical shell is at infinity. Now we consider a spherical capacitor whose inner spherical shell is grounded. Let us consider a spherical capacitor of inner radius R1 and outer radius R2. Inner sphere, that is sphere of radius R1 is grounded and outer sphere is charged by plus Q. Is charged by plus Q. Let us say this spherical shell is charged by plus Q. Now we know that charge resides on the outer surface of a sphere. But since in this case the region inside the outer sphere and region outside the outer sphere, there is earth or earth body. Is it clear? Since both sides of the outer sphere, inner side and outer side, both sides, there is earth body. So there will be charge on both sides. There will be charge on the inner side. There will be charge also on the outer side, because there is earth body inside and outside also. Let us say that in the outer side there is a charge Q1 and the inner side there is charge Q2, and also Q should be or Q must be equal to Q1 plus Q2. Capital Q, the charge given to the outer sphere, must be equal to Q1 plus Q2. This Q is divided into two parts. One portion resides on the outer side and one portion resides on the inner side. Now, due to this charge, there will be induced charge on the inner sphere. On the outer side of the inner sphere will be charged by minus Q, and inner side of the inner sphere will be charged by plus Q. Or you may say that induced charge on the inner side of the inner sphere will be plus Q, and this plus Q2 will be neutralized by the electrons coming from earth. So this plus Q2 disappears. Now you have to find out the potential difference between these two, or since potential of inner shell is 0 because it is grounded, so you have to find out the potential of the outer sphere. Now potential at A, potential on the surface of the inner sphere will be equal to or will be due to charge of minus Q2 and charge of plus Q. That means charge of Q2 plus Q1 and plus Q2. That is the potential on the surface spherical shell A, and which is equal to minus Q2 divided by 4 pi epsilon naught R1, and also it is on the inner region of the outer sphere, and for that case the potential will be equal to plus Q divided by 4 pi epsilon naught R2. You have to remind the previous results that if this is a charged body which charge plus Q, then the potential inside the sphere will be equal to Q divided by 4 pi epsilon naught R, where R, or put it capital R is the radius of the sphere, and also the potential on the surface of the sphere is this, but potential on the outer region, that is outside the sphere, if distance is R from the center, then potential is Q by 4 pi epsilon naught R. That means each and every point inside the sphere is potential this, which is fixed, but in the outer region of the sphere, potential is Q by 4 pi epsilon R, where R is the distance from the center of the sphere. Potential at this, right? Potential on the surface of the sphere A is equal to potential due to this minus Q2 charge, or potential due to its own charge, and potential due to the charge on the outer sphere. Potential due to the charge on the outer sphere is Q by 4 pi epsilon R2, and potential due to its own charge is minus Q2 divided by 4 pi epsilon 0 R1. But since the sphere A is grounded, so its potential is 0. Therefore, 0 equals to minus Q by 4 pi minus Q2, not Q, this is Q2, minus small q, divided by 4 pi epsilon 0 R1 plus Q divided by 4 pi epsilon 0 R2. Or we can write 0 equals to minus Q2 by R1 plus capital Q divided by R2, or Q2 by R1 equals to capital Q divided by R2, or capital small q2 will be equal to capital Q R1 divided by R2. That will be the charge on the inner sphere. Now you have to find out the potential at the surface of the outer sphere, that is Vb. Vb is the potential on the surface of the outer sphere, and that will be also due to its own charge, that is plus capital Q, and due to the charge on the sphere A, that is inner sphere, and which is minus Q. Therefore, potential due to its own charge will be equal to Q divided by 4 pi epsilon 0 R2. Using these results, and potential due to charge minus Q2, that is charge on the inner sphere, is equal to minus Q2 divided by 4 pi epsilon 0 R2. This is also R2 because the distance from the center of the sphere is R2. We can write 4 pi epsilon 0 R2. No. Then we can write, we make it outside, 1 by 4 pi epsilon 0 R2 capital Q minus small q, right? Or we can say 1 by 4 pi epsilon 0 R2 capital Q minus small q2 is this, Q R1 by R2. Or we can say 1 by 4 pi epsilon 0, or you may bring Q outside the bracket, then Q by 4 pi epsilon 0, 1 minus R2, no, R1 by R2. Therefore, we may write Q by 4 pi epsilon naught R2 minus R1 by R2 Here again 1 R2, that means R2 square. Is it clear? We have to put here also R2. 1 by 4 pi epsilon 0, Q minus Q R1 by R2. That means Q by 4 pi epsilon 0 R2, 1 minus R1 by R2, or Q by 4 pi epsilon 0 R2 minus R1 divided by R2 into R2, that is R2 square. Now, the potential difference is Vb minus Vm, which is equals to Vb minus 0, that means Vb is the potential difference. Therefore, capacitance C will be equal to Q divided by V, right? Or Q divided by V, that is Vb, is equal to this. Q divided by, no, this is 4 pi epsilon naught R2 minus R1 by R2 square. Or you can write 4 pi epsilon naught R2 square divided by R2 minus R1. You cancels out. 4 pi epsilon 0 R2 square divided by R2 minus R1. This is the capacitance when capacitance of a spherical capacitor when its inner sphere is grounded.